transfer function of casual LTI system is hz is equal to 1 minus z raised to minus 1 by 1 plus 3/4 z raised to minus 1. Then find the impulse response, find the output of system to the input, where xn is equal to this equation, and third one is system stable. So first part of the problem is calculation of impulse response. H of n. So now given, now what is given? Hz is equal to 1 minus z raised to minus 1, 1 plus 3/4 of z raised to minus 1. This is equation 1. Now we obtain Hn by taking the isolativity of Hz. Here we write obtain H of n by taking IZT of Hz using partial fraction expansion. So multiply numerator and denominator by z. So h of z is equal to z minus 1 by z plus 3 by 4. So multiply numerator and denominator by z. So it is hz by z is equal to z minus 1 by z into z plus 3 by 4. This is equation 2. Now the poles are, we write here, poles are at P1 is equal to 0 and P2 is equal to minus 3 by 4. We can create equation 2 in partial fraction expansion form as hz by z is equal to a1 by z minus 0 plus a2 by z plus 3 by 4. So here now we have to find the values of a1 and a2. So a1 is equal to z minus p1 hz by z, z is equal to p1. Now we substitute these values and we get a1 is equal to minus 4 by 3. a2 is equal to z minus p2 hz by z, z is equal to, that is minus 3 by 4. So we substitute these values and we get a2 is equal to, that is equal to 7 by 3. Now put values of a1 and a2 in equation 3. This is equation 3. So hz by z is equal to minus 4 by 3 by z plus 7 by 3 z plus 3 by 4. Therefore h of z is equal to minus 4 by 3 . We can write minus 4 by 3 plus z plus 3 by 4. Now this is equation 4. This is h of z. So the system is casual. We can obtain Hn as h of n is equal to Now the second part of the problem is calculation of output y of n. So first we write what is given. Given is x of n is equal to 1 by 3n raised by un plus u of minus n minus 1. Now take z transform. So x of z is equal to z by z minus 1 by 3, z by z minus 1. Since u of minus n minus 1 is minus z by z minus 1, and given h of z is hz is equal to z minus 1 z plus 3 by 4. Now hz is equal to yz by x of z. So we can write this equation as yz is equal to hz into x of z. So it is z minus 1 by z plus 3 by 4 into z minus 1. So again we can write it is z into z minus 1 divided by z plus 3 by 4 z minus 1 by 3 minus z into z minus 1 z plus 3 by 4 z minus 1. So by solving this equation we get it is z minus 1 divided by z plus 3 by 4 z minus 1 by 3 minus z by z plus 3 by, this is equation 9. Now consider, next part is consider yz is equal to y1 of z and y2 of z is equal to second part, that is z by z plus 3 by 4. Now first we take the first part, y1 of z is into z minus 1. Okay, z get cancelled, so it is z plus 3 by 4 z minus 1 by 3. So we take the partial fraction, that is a1 by z plus 3 by 4 plus a2 by z minus 1 by 3. Now by solving we get the answers. First we write poles p1 is 1 minus 1 by 3 and p2 by 3. Can find a1 as z minus p1 into y of z by, where z is equal to p1, that is it is 3 by 4. It is 3 by 4. It is 3 by 4. So by solving we get a1 is equal to, its answer is 21 by 13. It's 21 by 13. Next part is a2. It is z minus p2 not z by z. Z is equal to p2 is equal to 1 by 3. So by substituting this value we get a2 is equal to minus 8 by 13. Now put these values in equation 10. So equation 10 is y1 of z by z is equal to 21 by 13 plus, not plus, it is minus, as it is minus by 13 z minus 1 by 3. Therefore y1 of z is equal to 21 by 13 z by minus given system is schedule. This is equation number 11. Now consider y2z is equal to z by z plus 3 by 4. So y2 of n is equal to IZT of so the total output yn to y1n plus y2n. So yn is equal to addition of both these two. Addition of both, that is y1 and y2. Third part is deciding stability of system given transfer function. So it has pole at P1 minus 3 by 4. It is clear that the pole lies inside the unit circle. Inside the unit circle, when the pole is inside, then system is stable. Next problem, plot the pole zero pattern and determine the system stability. Now this is given equation, So now take IZT, that is inverse Z transform. So we get y of z is equal to minus 0.5 z raised to minus 2 y of z plus x of z plus minus 1 x of z. Therefore y of z minus z raised to minus 1 x y of z plus 0.5 z raised to minus 2 y of z is equal to xz is common, taken outside the bracket 1 plus z raised to minus 1. Now here also yz is common outside the bracket, in bracket 1 minus z raised to minus 1, 0.5 z raised to minus 2 x of z is equal to 1 plus z raised to minus 1. So we can write equation yz divided by x of z is equal to h of z is equal to plus z raised to minus 1, 1 minus z raised to minus 1 and multiply by z square. So now we obtain roots of denominator. So roots are p1, p2 plus minus root of so these values are 1 plus minus 1 minus 2 divided by 2, so it is 1 plus minus 1. So roots are p1, it is 1 by 2 plus j 1 by 2. So p1 is 0.5 plus j 0.5, 1 by 2 is 0.5 and p2 is equal to 0.5 minus j 0.5. Now equation 2 becomes h of z is equal to z minus 0 z plus 1 divided by z minus 0.5 j 0.5 now zeros are at z is equal to z1 is equal to 0 and z2 is equal to minus 1. So the pole 0 plot we have to draw here. This is Z1, this is 0.5 P1 and this is P2. So pole 0 plot is shown here. Since both poles are inside the unit circle, system is stable.